cross-site request forgery, that's along the lines of what we're talking about. Okay, I've already had an introduction. I want to point out a couple of other things on this slide, specifically at the very bottom. I'm a runner. I'm actually training for my first half marathon. The picture on here is me doing my first Tough Mudder. So any Tough Mudders in the room? We got a couple? Yeah. It's a lot of fun. My brother, who's 10 years younger than me, actually got roped into this. He does ultra marathons, so I don't know what I was thinking to actually get involved in one, but it was cool. I actually signed up again for this year. Also a home brewer. Any home brewers in the room? There better be a few of you. Yeah, home brewing's fun. Okay, so why are you here? Or what's this talk about? So maybe you've heard about the terms cross-site scripting, cross-site request forgery. You're not entirely sure what all of them mean. Maybe some of the other ones like CORS. Anybody heard of CORS? Do you really know what that means? So I'm going to actually walk through what some of these terms mean, and hopefully give you a better idea of what you can do with them, and in which ways they can be used, or in which ways they limit you. Maybe you need some help explaining some of these terms to your not so technical business partners, or maybe you're just looking for inspiration on different ways you can use these things. So, or maybe you're just getting a good seat for Smirker's talk because we're in such a small room. So. Okay. Anyway, whatever your reason is, okay, I'm going to focus on 3 of the OWASP top 10. So if you're getting into web application pen testing, or if you do web development and you haven't actually looked at OWASP, that's something you really need to do. Okay, the OWASP.org website, it's not just the OWASP top 10 that's on there. There's a whole bunch of other stuff. Lots of cheat sheets and tools. All of it's free. Totally worth taking some time to look at it if you haven't done that. All right, so let's get into the first one. I'm going to talk about cross-site scripting first. This is going to take the most time, and it's because it's probably the most important one. So it's been around for a really long time, but it's pervasive. It's still all over the place, and in some ways it's actually even maybe getting worse. It's a cornerstone of a lot of phishing attacks. So once we get away from the somebody just blatantly trying to convince you to enter your credentials, you're talking about cross-site scripting, that's the, can I get you somewhere where I can potentially steal your credentials right out of a form, or steal a session or something like that. There's some mechanisms built in to the whole to the web, the browsers, that will help prevent some forms of cross-site scripting, but none of them have ever proven to be 100% effective, and I'll circle back on that. But it's just like anything else, right? There's nothing that's ever 100% secure. So some examples out there. Now, what I did at the beginning of this year, I wanted to get a better beat on what sorts of cross-site scripting is out there and how bad is the problem. So I set up a Google alert. I know it's a Google thing, but it's a Google alert. Daily, I get basically a digest of all of the newly reported articles out there that mention cross-site scripting. And I actually get, I was hoping that it would be some huge number that I could really wow you with, but it's actually not that bad. It's more like probably on average 5 or 6 a day. But that's still quite a bit, and they all stack up. So here's some that are from, I just picked a few randomly that I recognized that are just this month. These are things that have just come out this month. So IMDb had a cross-site scripting vulnerability on it. That's something we've probably all seen. Anybody not heard of IMDb? WordPress. So there's a WordPress plugin. I know WordPress, everyone says that WordPress is not secure. Here's an example. It's the WordPress plugins that are really insecure, that have a lot of problems. In fact, there's a whole tool dedicated to scanning WordPress plugins looking for vulnerabilities. WP scan, so if you're not incorporating that in when you have a pen test, then that's maybe something you want to look at. So anyway, this particular one, I took a look at the WordPress website. There's actually over 1 million active installs of this plugin, and it has a cross-site scripting flaw built into it. So all of those WordPress sites that have this are potentially vulnerable to cross-site scripting. And Bugzilla, I know it's an oldie, but it's a goodie piece of software that for bug tracking. So that's another one that's very recent. If you're not into just random mail articles looking for this sort of thing, we can also look at CVEs. And I know the print on these are really small, so I'll just highlight a couple of these here. And again, these are all really recent. So we have IBM Rational Quality Manager. Okay, you're probably not going to run across this on the internet very often, but inside a corporate environment, this is a fairly popular tool. I mean, we're talking about clients who can actually afford IBM products who would be vulnerable to this one. Next one on there, Microsoft SharePoint. Does that sound like a big deal? Anybody know anybody who uses SharePoint? So it's a good place to find a cross-site scripting flaw, right? And the last one on here, I kind of cheated. This one doesn't really belong on this list, but it is mentioning cross-site scripting. So Internet Explorer, it's actually not a cross-site scripting flaw. It's a flaw in one of the protections for cross-site scripting. And I'll circle back on this one later on and explain it in a little bit more detail. So what is cross-site scripting? We've all heard the term. A lot of us have this idea in our head of what it is. Wikipedia says, and I'll just read this to you, cross-site scripting is a type of computer security vulnerability typically found in web applications. XSS enables attackers to inject client-side script into web pages viewed by other users. This is correct. I mean, it's an accurate description. But when we hear the words cross-site scripting, is that really what we're thinking? Or are we thinking that maybe there's a script on one site that's somehow talking to content on another site somewhere? To me, when I first heard cross-site scripting, that's what I was thinking. So the term itself is a bit of a misnomer, and it doesn't actually require scripts to be on two different sites. In fact, there's a whole flavor of cross-site scripting, stored or persistent. You've probably heard of that one at some point. That is all on one site, right? You inject it on that site, and then the victims are going to that same site. So there's no second site at all involved in that. So I prefer to think of it as browser script injection. That's really what we're talking about. So when we talk about browser script injection, what type of script are we talking about? It's going to be JavaScript, usually, right? Normally, JavaScript is what we're talking about. That's the universal scripting language of the web. That's what every browser out there that you're going to encounter these days, they all support JavaScript. But don't forget about VB script, especially if you're doing tests in a corporate environment where Internet Explorer is a standard. In those cases, it is possible to run into situations where your JavaScript payload may not work, but a VB script payload will. So there are some differences in special characters there that you want to pay attention to. So browser script injection. How do we get that to work? It requires two things to be in place for browser script injection or cross-site scripting to actually work. The first is you have to get your injection into the right context. And what I mean by that is it has to be in an executable context. It does no good to have, due to encoding or whatever, to have script tags injected that don't actually execute because it still considers, the page still considers it to be data. So we have to get your injection to be considered something that's actually executable. The second thing is you have to have execution, and this becomes really important, especially when you're looking at DOM-based cross-site scripting attacks, and I'll go over the differences a bit later. So DOM-based, it actually, you run into situations often where you'd be able to maybe get your injection into some piece of code, but it's code that never actually gets called on the page, or it's been called before it gets injected and not after. So that ends up being something that you have to resolve as well. But once you have those two things in place, you can have successful injection. So for those who haven't seen cross-site scripting before, let's back up and we'll go to, this is the simplest example out there, okay? So how does injection work? This is just, I'm not talking about injecting anything bad at this point. I'm just saying, okay, we have an input, right? Name equals Bob, okay? And the response that comes back inside the HTML DOM includes the same thing that we put in the input, Bob. So in essence, all we're doing in cross-site scripting is we're taking Bob and we're saying, okay, well, let's add something that breaks us out of the data context, so that's what the script tag does, and puts us into a context where the browser says, hey, I have something I can actually run now, I have some code. And in this case here, it's the simplest example we have, which is alert 1. So what happens when this page renders? Of course, we have a pop-up box. Everyone's seen the pop-up box before. And we get in trouble for putting these on reports sometimes because managers are like, I don't know, I don't see anything wrong with a pop-up box. How's that hacking me? So we'll get back to some better ideas there instead of pop-up boxes in a few minutes. But before we do that, let's just take a look. Take a second, take a step back. I'm not going to read this whole slide to you, but take a look at JavaScript. So this is a brief history of JavaScript. What you'll notice is JavaScript has been around since May 1995. Okay? It's 20 years old. This is ancient technology. Why do we have such a pervasive problem in 20-year-old technology? But it's there. Okay? There are probably some people in this room who are younger than JavaScript. Let's be serious, it's been around that long. The other piece of information I want to bring your attention to is the last one on there, so 2005. So this new HTML5 thing called Ajax is really not that new. The term was coined in 2005, so that's 10 years old, and believe it or not, you could actually do all that stuff long before the term was even coined. Okay, the whole web remoting capability, that was around before 2005, so this is not news. So this kind of leads into, we have this DOM-based cross-site scripting. It's actually not that new. We're only just starting to discover it out there, but it's been around for a really, really long time. So back to the pop-up box. We don't like pop-up boxes by themselves. We need some better ideas. So what are some other things we can do with JavaScript? Because if we can do a pop-up box, we can probably do just about anything else that we can do in JavaScript. So let's just look at a couple of these things. You can read from and write to the document object model. Okay, the document object model, that's basically the HTML that comes back in the request gets interpreted into a tree-like model of all of the elements. And we can manipulate that with JavaScript. You can read cookies and headers. Okay, so this is how we do. This is how we steal sessions when we don't have man in the middle. It's usually done through JavaScript. We can detect keystrokes and mouse clicks. So you can do a rudimentary keylogger in JavaScript. Stream media. Now, I keep wondering if this is, it doesn't really seem like a big deal. Oh, you can turn on the webcam. But I keep thinking that this might actually make some really compelling examples, especially if you're doing a test in a corporate environment. Because, if you've got a snapshot of the CEO of a company, that's going to be pretty compelling, I think. But I was also thinking about the other type of media that you might have access to. For one, there's a microphone, so you could eavesdrop. And I don't know for sure that accessing the microphone will actually turn on that little light. Right? So there's a possibility there. It doesn't turn on the light. So you can eavesdrop on somebody and they have no idea. They have no indication. And I was also thinking that it would be kind of fun at some point. I haven't done this, but it might be fun to actually make use of the speakers. So when Bob's computer starts talking to him and he starts going kind of nuts, you have some evidence there. So I thought that would be kind of fun. You can do screenshots. You can do fetch more stuff through Ajax. So this allows you to do kind of staged attacks. So maybe you can only put in a small payload initially. You can use that to then bring in larger payloads and do more. There's whole tools dedicated to this. I'll circle back on that as well. Open WebSockets. There's a whole lot of stuff you can do. If you really want to know all the things you can do with JavaScript, you really need to learn JavaScript. All right. So with all of this stuff that we can do, we can make requests out to things. We can turn on webcams and all this stuff. you have to wonder why like the whole internet, why isn't it compromised just through cross-site scripting attacks alone? And the answer, the main answer for this, is something called SameOrigin Policy. We've probably all heard the term. I'm going to explain it for those of you who use the term and not really sure what it means. So first of all, let's talk about an origin. This is important to understand because this is when you're trying to do your cross-site scripting attacks and for some reason it's not working the way you're expecting, your request is not getting through or the information is not coming back. This is something you need to really consider and take a close look at and remind yourself. Okay, so the origin is made up of 3 pieces. You have your protocol or scheme, you have your host, and your port. Okay? If any one of those is different, then it's considered a different origin. It's not the same origin. And this is key to remember, especially, I mean, you have cases where you have the same content served over HTTP and HTTPS. Okay, it's 2 different ports and 2 different protocols. Those are considered completely separate origins as far as the browser is concerned. Okay, the policy itself, so it's enforced on the browser. And according to this policy, code running in one origin is not allowed to access the document object model on another. Okay, so it can't actually access the data. It can't manipulate it in any way. So it's this nicely fenced-in capability within the browser to make sure that if you're accessing content on different origins, you have your code running in one, it's not able to actually get to another one. So this is why you can't have a cross-site scripting attack on one origin that goes out and fetches a cookie off of another one. This is what's preventing that from happening. Okay. Which is pretty awesome for a security feature, right? It really helps segregate things, except in cases like this. So I know this is probably very small. This is that same CVE I popped up earlier. So I think it's 2015-0072. You can look it up later. And I want to spend a little bit of time talking about this. We have Internet Explorer 9 through 11. If it's unpatched, because the patch just came out last week. This was announced at the end of January. So there's a whole month and a half that went by where there's no patch available. And what this does, this is a vulnerability just in the, you can basically work some JavaScript magic to get around the SameOrigin policy so that you can inject use cross-site scripting across multiple origins. And it just completely ignores the SameOrigin policy. You can get right past it. So when you're doing your pen test, and I don't know of any exploits out there yet for this, but I wouldn't be at all surprised if someone started developing some. When you're doing your pen tests and you find browsers that are unpatched against this, you're probably going to be golden for being able to do things like collect session cookies. As long as the cookies are not set correctly, which they usually aren't, you'd be able to. So it's definitely something to look at there. So there are some exceptions to the SameOrigin policy because we can't have everything boxed off like that. The internet just wouldn't work the way people want it to. So there's a few things. First of all, there's the script tag. I mean, that's the obvious. So if the way the script tag works, you can grab scripts from other places. I mean, that's part of the way the internet works, right? Everyone has jQuery libraries in other places, and they load them onto their page, and then they're able to actually run them. So there is some interaction between scripts, but scripts aren't data. The way that you can interact with data, or one of the main ways that's come out as of HTML5, is the CORS policies. So cross-origin resource sharing. And this is basically the magic that makes HTML5 as we know it today actually work. So instead of just bringing content from different places and putting them into different iframes, your developers can now take content from different places and easily actually have that content interact. So they can take data from one area and data from another area and do some arithmetic between them, put the results on the page, and all of that actually works now. So the way that it's set up is it's it's a policy for, so basically it's for removing same origin policy restrictions on a case-by-case basis. So a particular server can say, okay, in general, we have same origin policy, but I want to allow connections from a specific origin. Or maybe I want to allow them from all because I have some kind of public service out there and I don't care who accesses it. That's the global policy, which I'll get to momentarily. And the interesting thing, okay, so I did some experimentation with same origin policy in the fall last year, and I found a couple of things. It's defined on the server, but it's the enforcement, the role of enforcement is only on the browser. At least that's the way it's written in the spec. So it's possible, and this was for what I tested, which I just tested under Cherry Pie mostly. And what I found was, although you can define the policy on the server side, the server didn't enforce its own policy. So what I mean by that is, if some AJAX actually made a request to a server that had the CORS policy in place, even if the origin didn't match one of the origins on there, it still responded. It still sent a response back with the content that it was asking for. It left it up to the browser on the other end to say, oh wait, I'm not actually supposed to receive this, so I'm going to throw it away. Which is kind of interesting. It made me really start thinking about, are there ways that you could maybe trick the JavaScript into going into a success block and actually accessing that content? I haven't found one yet, so if anyone does, I'd really, really like to know. So let me illustrate this a little bit more, because I know CORS is something that's kind of nebulous and people don't usually spend a lot of time looking at it. So basically we have two servers out there. We have foo and we have bar, okay? Foo inside of some JavaScript says, okay, I'm going to create an XML HTTP request object. And it's going to request some content from bar. When it does this, the browser is going to add the origin header. So it's going to say, hey, I'm making a CORS request. Here's my origin header. That's the only indicator that that is a CORS request. There's nothing else in that request that tells the server that it's a cross-origin request, except for that origin header. So when the server sees an origin header, it's going to respond back with its policy, which is on the bottom left there. So we have access control, allow origin. That's the main response header that we're going to see. The other ones are optional, but that's the main one that we're going to see. So it's going to respond with its normal response. Like I said before, it leaves the browser to do the actual enforcement of the policy and whatever the policy headers are. The other interesting one on here is the allow credentials. And what we mean by credentials is cookies. We're talking about sessions. Okay, that's what credentials are considered in the CORS policy. So if I make a request and I say this request is with credentials, then it's going to also send any cookies, any currently active valid cookies associated with bar in this case on that request. So it ends up being an authenticated request. There is one exception to this, and this is kind of important for us to realize, especially if you've been running scans and you get that warning, hey, there's a global CORS policy where they've used star as the allowed origin. The browsers will actually ignore the credentials setting if there's a global policy in place. So it's really not as bad as the scanners say. I actually tested this out, and that's the way it works. The browser says, oh wait, you have a global policy in place, forget the credentials. So I believe it actually still sends them, but it always errors out on when it gets back. So once it comes time to enforcement, it's going to fail. So really where you want to look during your pen tests, and I don't know of any scanners that actually do anything like this right now, so this is going to be some of your manual testing if you're doing your web app pen testing, is take a close look at, when you look for CORS policies, and take a close look at which servers are actually allowed according to the CORS policy, because it's those hosts, if you find a cross-site scripting flaw on any of those hosts, then you'll be able to use that flaw against that target server that's hosting the CORS policy, as if it's within the same origins. Basically, stretching out its SameOrigin policy to include additional hosts on there. So keep that in mind when you're doing your test. So three flavors of cross-site scripting. There's really only the first two. The third one is kind of a different spin on the first two. So we have reflected, which we went over. That's Bob, right? And Bob came back on the page along with the tag with the alert 1 box on there. And then we have stored. So for stored or persisted, it's called different things. What we're really talking about here, this is the blog comment thing, right? Where you get some script onto a page somewhere, and as various people visit that page, they don't have to re-inject the script every time like Bob would have to on his reflected. It just shows up for everybody and executes for them. Then there's DOM-based. And this is the one I think a lot of people have a really hard time wrapping their head around. How does this work? I actually had a very hard time coming up with any way to illustrate this, so I'll try to explain it. Basically, DOM-based, what it means is the response that comes back does not include the payload that you put in. Okay, so normally in reflected, remember we had Bob, name equals, and then it was script alert 1. You'd put that into the input, but then the output that comes back, that script tag isn't there. But it still ends up in the DOM. And the reason it ends up in the DOM is because there's some JavaScript running. I'm losing my audio here. There's some JavaScript running somewhere down the line that actually pulls content from various different places, maybe headers, maybe cookies, maybe a URL parameter, and it puts that in, it actually shoves that into the DOM. And we're actually seeing more and more applications do this. This is the way they're built now with HTML5. You take a look at the initial response back, you know you have those applications where basically the page comes back almost empty. There's very little content on it, yet it gets populated with all kinds of content dynamically. That's how that's working. And that's where your DOM-based cross-site scripting flaws are going to be. They're going to be in those types of applications.
Yeah, I spent 3 classes trying to wrap my head around how it works and how to find people have to test for it.
Yeah.
And the closest strategy I came up with, because if you look at just the whole DOM, spec Gillam, it's a massive ASCII value.
Yeah.
So what I was thinking is that I should look at parts of the page that take for info, like certain boxes and things like that. Am I far off the mark there?
No, you're still looking at the right thing. So what he's saying is he's trying to figure out, how do you find this stuff? Where do you look? And how do you verify it? Unfortunately, it's really hard to verify. I mean, it's really hard to find and verify, and that's the big challenge with it. I mean, like I said before, it's been around for over 10 years, the capability to do this, but we still don't have really robust ways to detect it. It is getting better. There's scanners out there getting better.
Well, I mean, I can open up the DOM and rewrite like titles of pages and stuff like that. Enter the changes and hit enter. The DOM gets changed. All right.
Yeah.
But the way it's explained in YouTube, you're supposed to find the injection or string, okay, the info value, and then inject the little script alert on there, and then something happens.
Right. Yeah. I'll get with you afterwards. We can go over it some more if you want. But yeah, basically, finding it is starting to get a little bit easier. Tools are out there that are able to find it either through static analysis or by actually executing JavaScript. Because if you look at most of the scanners out there, they do what I was basically saying before. They try inputs, so they basically do fuzzing on your inputs, and then they look at the response, just the response HTML when it comes back, and if they see the payload in the response, then it says, hey, yeah, it looks like cross-site scripting here, go check it out. But in DOM-based, you're not going to find that unless it's actually executing the JavaScript. So now, I will say this, if you are playing around with DOM-based a lot, one tool that's really helpful for that is Firebug. So With Firebug, you can actually do JavaScript debugging, which allows you to set a breakpoint somewhere in your JavaScript, and you can start tracing your way through. It means it's a very manual process, but you can start tracing a value through, so you can kind of see how your payload is getting somewhere, which becomes fairly important, especially when you have those really, really heavy JavaScript-laden pages. So, okay. So we're tired of pop-up boxes. We want some other ideas. So I gave you some ideas already. If you're looking for more, strongly recommend that you take a look at Beef if you have not looked at this. Even if you have, go take a look at it again, because Beef, the browser exploitation framework, is a framework that has all these modules in it. By the way, guys, there's lots of space over here if you want to sit down. So there's a lot of, it has a lot of modules in there that do a lot of different things. So definitely pull that up and take a look at it. It has some other really interesting capabilities in there. During a pen test, there's the XSS Raise, which is a cross-site scripting scanner that's written all in JavaScript. So basically, you compromise a browser, and then you make use of that browser to do additional scanning for other cross-site scripting flaws. That's kind of cool. Also, it does there's a tunneling proxy capability in there. I mean, there's some limitations, of course, because of SameOrigin Policy, but it'll allow you to do some level of proxying your requests. So you think about a scenario where your victim is inside a firewall, and you've managed to actually compromise them, so you're able to communicate with their browser. You can then use that connection to visit other websites internally. So that's pretty cool. And you don't even have to install it. In fact, I recommend you try not to run into a situation where you have to install it, because it is Ruby. So I don't know if any of you have had experience try to install Ruby stuff. I know, a lot of people are perfectly fine. I always have trouble. It never seems to work for me. I'm always looking for the wrong gem, I guess. But anyway, it is available on Kali and Samurai, so you can just pull up either one of those live environments, and you can just launch it right inside of there and play with it. So. All right, next we have redirects and forwards. So redirects and forwards are a very normal part of how the web works, right? We try to go to a web page on a web application. It says, hey, you're not logged in. I'm going to redirect you to your login page. So this is where all your 300s come in, right? Your 300, 301s. And then you also have the, okay, well, now that I've logged in, bring me back to where I was trying to get to in the first place. And then we have another redirect. There's also various redirects for things like, going to affiliate site or going to get content to another place, or we have mashups of multiple applications that are trying to look like it's all one application. So we have a lot of that kind of stuff happening. Redirects are very straightforward. Here's a very typical example. We find this in a lot of applications, right, where you have on your login page, it says, hey, the URL that you're going to try to get to once you've finished logging in is this one here. So we're on login. We're going to look for account. Now, an unvalidated is when the server doesn't actually check to see where they're sending the user. So it's actually trusting that URL parameter that's coming from the browser and saying, hey, all right, you want to go there after? That's where I'm going to send you. Okay. So in this case, we're going to evilhacker.org. So what can you do with this? I mean, if a user clicks on a link, so this would be something that's probably going to be distributed in a phishing attack. They click on a link, they log in, and then they end up on this evilhacker.org site. And they're going to know, hey, something went wrong. I'm in the wrong place, right? Or will they? So this is where I like to do something called an evil twin login. So how about they log in, and then on the evil hacker site, you basically have a replica of their login screen. So it looks the same. Maybe actually you put a message on there that says, hey, you screwed up, you fat-fingered it, try logging in again. So what happens is they log in the second time, because they just, oh, yeah, okay, whatever. You know, people, they're not going to pay attention to the URL the second time around, right? And then you redirect them back to the site that they originally logged into. So they don't know that anything went wrong, but somewhere along the way, they actually typed in their username and password on your website. So guess who has their username and password? A really, really cool place to find this is on single sign-on pages. So you go into a corporate organization, because, I mean, people don't really think about it. It's single sign-on, oh, I got to type it in again. Oh, I got to type it in again. They don't even stop and think about it. So that's a really great place to find this kind of flaw. Combine redirects with cross-site scripting, and what do you get? First of all, you can make more convincing phishing links, maybe, okay? But the other thing is you can get your cross-site scripting payload, you can make sure that it gets into actually an authenticated part of an application, because you may be able to pass your cross-site scripting payload in as part of that URL parameter. Right, so that's a place where you want to look at that. So you're looking for cross-site scripting flaws inside of the authenticated space of the application, and make use of the open redirect to actually get it into the right place. Okay, the last thing I want to cover is cross-site request forgery. So this was another one that's been around for a long time. It's been around as long as browsers have been able to handle various different concurrent sessions, so different websites at the same time, which was probably before browser tabs, but I usually like to think about it as browser tabs because it's just the easiest way to conceive this. So basically, as long as there have been multiple browser tabs out there, we've been able to do cross-site request forgery. It's a very normal part of the way the web works. Okay, we have web pages all the time that are doing things like going out and getting an iframe and bringing in content from somewhere else and displaying it on the page, or bringing in images from other places or scripts, or we have likes on our whatever our favorite social media is. So that's cross-site requests. Now we start talking about the forgery, and how does that work? It starts with the fact that we have things called cookies. And cookies are usually, these days, they're sessions, and they're used to basically the gatekeepers for accessing your the content that you've logged in order to be able to get to. So it's your more sensitive functionality, right? And so what we do is we're going to make use of the fact that if you have multiple tabs open in your browser and a request originates from any of those tabs and goes to one that you've already have an active session on, your browser's still going to send the cookies to that one even though you've started on another page. Okay? That's just the way it behaves. The other aspect of cross-site request forgery is something called predictability, right? So we need to make sure that the parameters are parameters that your attacker can actually guess. So an example might be, let's say you have a stock application, and in order to buy stocks, all you need to know is a stock symbol and the number of stocks that are being purchased. Okay, so it's just two parameters. If that's all that's required, then that would be a cross-site request forgery type of scenario. So it's some piece of functionality. Interesting thing about cross-site request forgery, it doesn't require any scripting. I just said we can use image tags, we can use iframes for cross-site requests. So there's no need to do scripting, which means because there's no code running, it's not subject to SameOrigin policy. So this is something that you can do across different sites. So what happens if you combine cross-site request forgery with cross-site scripting? It becomes extremely useful. If you have a cross-site scripting flaw that's on the same origin as your cross-site request forgery flaw, or remember I was talking about CORS, how CORS basically extends your what is considered under SameOrigin policy. If it falls into a policy and is actually allowed there, then you can basically bypass probably the most common cross-site request forgery prevention out there, which is the tokens. Okay, because you can make a request, and because it's considered same origin, your script can actually access the response of that request. So you can make one request, get the token, and then make another request with that token, and basically bypass whatever protection was there, and run whatever the sensitive functionality was. So. In fact, if you look at Beef, and you look down the list of it's under I think it's the exploits tab under there, and this is just a small snapshot of it. So going back into Beef, you'll find that a large percentage of the Beef exploits are actually cross-site request forgery payloads. So those two work really well together. And there's one other scenario that I want to mention before I wrap up, and that is the using cross-site request forgery along with an unvalidated redirect or an open redirect. So here's another interesting idea. So let's consider this. The user clicks on the link, because users click on links, right? They get to a login page. They log in. And then what you do is you redirect them to a page where you have, through the redirect, you redirect them to a page where you have your cross-site request forgery all staged and ready to go. They basically activate the cross-site request forgery, and then they get redirected immediately back to the site that they were trying to log into. So from the user's perspective, all they did was log in. There's nothing special happened. No second login page showed up. Their browser seemed to flicker to a different site, but then it came back to where they were supposed to go to anyway. So that doesn't seem like a big deal. And you were able to actually activate the cross-site request forgery in sort of a disguised mode, I guess. So that's something that's worth considering as well. If you find those two together, no scripting required for this. I mean, this is something you can do without any cross-site scripting or JavaScript. So in summary, this is all of the things we went over. My little cheat sheet here. So we have cross-site scripting or unvalidated redirects, CSRF. We talked about SameOrigin Policy. We talked about cross-origin resource sharing, or CORS. And we talked about what are some of the different things we could do when we combine these. So hopefully everybody learned a little bit of something here or there or got some ideas off of this. Anybody have any questions?
You're using an example of cha-ha.com. What is that?
So cha-ha, okay. So I meant to go over this at the very beginning. So something a few of us in Charlotte recently put together is a Charlotte Hackers Anonymous group, which is not so anonymous since you know who we are. But basically, we just get together once a month, do some hacking on a Saturday morning for a bit, and then we have a social afterwards. We have lunch, have a couple beers, basically have a good time. So and it's all free. It's not, it's not sponsored by anybody. We just kind of get together on our own for it. So if that's something that you're interested in, you're in the Charlotte area, especially if you're having trouble getting to some of the other organization events because they're too far away from where you live, we meet in South Charlotte. So Charlotte folks who live in that area, feel free to join us. We have a website, cha-ha.com, cha-ha.com.
Doing some work with the tokens, the anti-cross-site tokens.
Mm-hmm.
The only two methods I found that weren't kind of idiot-proof were the recursive grep and burp, and then doing a whole full-blown recording of the session thing somehow. Do you know of any idiot-proof way, either inside of burp natively or a good third-party tool you sort of kind of have recommended to make that process kind of idiot-proof?
What do you mean by
the anti-cross-site request forgery token? So when you're testing parameters, pulling that token every time, it'll make that process idiot-proof.
So a way to make the process of pulling in tokens
Basically,
idiot-proof.
Sites that use the...
That have the protection on them?
Yeah. When you're testing those, you either have to use from what I can understand, you either have to use the recursive grep or use a full-blown record session convert.
Oh.
Do you know of an easier way to do that that's more idiot-proof, or you have to use recursive grep or this record full session thing?
No, I can't think of anything else. I mean, I usually do the recursive grep.
I don't know if any of the commercial applications did it, or anything like that.
Not that I know of. Anybody else know?
It's just me.
It's just you. Anything else? Okay. Thanks a lot. I'll